You may have heard someone say that the rays of light coming from the sun are parallel. How can that be if they radiate from the sun in every direction? Well, the sun is really big, and it's also really far away. I'm going to demonstrate that using some simple Python scripts. As you can see, the sun is about 150 million kilometers away from Earth. And, even magnified by 10, the Earth is barely visible. If we zoom in a little, we can see that the rays of light seem parallel, and we also see that the Earth, even magnified by 10, is still barely visible. Zooming in even more, and we can see that without the grid lines we wouldn't be able to tell. They look, for all intents and purposes, parallel. If we get really up close and personal, we can see that the rays of light from the sun aren't in line with the grid, but they do look parallel to our eyes. Our eyes aren't great for precision measurements though, so we can do a little bit of trigonometry and see that from the top of the Earth disk to the bottom, there is only 5/1000ths of a degree of angular spread. So while not exactly parallel, it's definitely close enough to consider them parallel. How does that translate to the curved surface of the globe? Well, it all depends on the angle of the light across the surface. So the rays come in parallel, but they are distributed across a curved surface, leading us to have colder poles, and in the equinox we can see that it's relatively evenly distributed across the planet because the tilt of the Earth is not towards or away from the sun. However, in the June solstice we can see that the northern hemisphere gets more sunlight. It's important to note that in this plot the x-axis has been reversed and the sun is to the right. And in the December solstice we can see that the southern hemisphere gets more sunlight. We see here the sunlight has rays coming out in all directions, even though we decided that they're close enough to consider parallel. It's a matter of perspective, the same way we can see with these train tracks. The train tracks are definitely parallel, but they appear to converge in the distance. We see the same thing happen with crepuscular rays in the sky. It's a matter of perspective. However, there's a little more involved there, which I'll let renowned meteorologist Alan Seales tell us about.
It's not unusual with the cloud passing over to see the shadow of the cloud and to see the light rays fanning out through the cloud. We call those crepuscular rays. Obviously, clouds make shadows, but once the sun is down, sometimes the clouds are so distant you can't see it, but you can see the shadow. Look at this video. It shows to the west, parts of the sky are dark. That's the shadow of a distant cloud. And then if you turn around and look to the east, you also see the sky bright on one side, dark on the other. All of it due to shadows of clouds way in the distance. Pretty common, especially at sunset. You'll also notice it at sunrise, and it's way more noticeable when the atmosphere is very hazy. Simply cloud shadows. I'm meteorologist Alan Seales.
Thanks, Alan. I'm going to leave a link to his full video in the description, as well as a link to his channel. He has some phenomenal content that you'll really want to watch. Anyway, thanks for watching. We're quickly on our way to 11 bajillion subscribers or whatever, so, push some buttons or something.